What's up, guys? Today's video is going to be about rules for logarithms. And so the first one we're going to talk about is the change of base formula. Change of base formula, as you see here. So as you have log base b of a, then you can rewrite that as log a over log b. Now, in fact, you can use different logs here. Notice that the b over here is not the same over here. So while this has a base of b, which could be anything, these logs over here can be anything as well. The key is that they have to be the same. So a lot of times you'll see people write this formula a little differently. It'll say log, and it'll have some base here and some base here that will notably be different than this one. But for the purposes of this class, I wanted to just focus on the most useful case, which is to say log, and remember, if you don't put a base here, that means it's a common log or log base 10. The reason this is useful is because it allows us to evaluate logs using our calculator. So we could, in this case, say log 2 of a over log base 2 of b. Or you could say base 3, or you could say base 4, whatever base you want to put here, base x, it doesn't matter, as long as it's the same. But using base 10 is going to be the most useful. So here's an example of why we do this. If I say log base 5 of 7, I can simply rewrite that as log 7 over log 5. Remember that the base here is 10. It could be anything you want it to be, but using 10 allows you to put it in your calculator. Remember that log base 10, which we just call the common log, is a button in our calculator. So you can type in your calculator log 7 divided by log 5. Make sure you close the parentheses when you type it, and you'll actually get 1.21. That makes sense because 5 to the first power is 5. 5 to the second power is 25. Well, 7 is somewhere in between those, so the answer should be somewhere between 1 and 2. 5 to the first and 5 squared. Somewhere in between there is 7, and that's why we get the answer 1.21. So 5 to the 1.21 power equals 7. Okay, so there's some other rules we want to talk about which are used a little bit differently. The first one is the product rule, and it looks like this. And pause it if you need to write it down. I'm going to keep moving. So the base is b. Now notice the base is b all the way across. And again, that base can be anything as long as the base is the same for each of these. And what we're saying is if you have a log of something and a log of something else that you're adding together with a common base, we can multiply what's inside those logarithms together and write it as one logarithm. So for example, log base 4 of 5 plus log base 4 of 3x. I can add these together and put them into one logarithm by multiplying what's on the inside, which is 15x. Remember to pause it and rewind it, play it again if you need to. Trying to speed up. So quotient rule, log base b of m minus log base b of n with a subtraction sign in the middle. It's very similar to the product rule. Instead of adding, you're subtracting, and so on the inside, instead of multiply, you divide. Really, these are the same rules, just thinking about them backwards. Of course, if adding means you can multiply on the inside, then subtracting means you can divide on the inside. Really two different ways of looking at the same process. And as an example, log base 5 of 6x minus log base 5 of 3y. Again, got to have a common base, but we do. So then on the inside, since I'm subtracting, I'm going to divide 6x over 3y. Write it as one logarithm. Now I just need to reduce that fraction as always, so 6 over 3 is 2 on the top, and then you got an x and a y left. And the last rule we're going to talk about is the power rule, which really, again, these are all kind of the same rule. This is really an application of the product rule. If you ask me about it later, I'll show you if you ask me in class. So the power rule, we have log base b of m to the n power. If everything in parentheses is raised to a power, then you can bring that power out as a coefficient. So log base b of m to the n is the same as, pull it at the outside, n times log base b of m. Again, remember that everything in the parentheses has to be raised to that power, which in this case, since only m is raised to the n power, everything is raised to the n power, so I can pull it out. Here's an example. Log base 6 of x to the 4th, that's the same as saying 4 times log base 6 to the x. A new vocabulary word we need to talk about is a natural log. And the only reason it's coming up now is because we're going to use it in some examples. And kind of like the common log, it's just a special type of logarithm. ln of x really just means log base e of x. And e is actually a constant. It's just a number, kind of like pi. It's a symbol that represents a specific number. It's not a variable. And that number is what's called Euler's number. But it's used in a lot of different applications in compound interest and some other places. For our purposes, just remember that this is ln. ln is log base e, kind of like the common log, which you already know. Log with no base simply means log base 10. This simply means log base e. It's also a button on your calculator, which you can look for. All right, so we're going to look at some example problems, how we would use this. Okay, these product, quotient, power rules sort of used in conjunction. There's two basic types of problems you're going to get here. One is going to be to expand, where you've got a bunch of stuff inside the logarithm. Now, everything here is inside the logarithm, even though it's not in parentheses, because it's all one term. Although really we typically want to write it in parentheses. I didn't really have to. The way it was written, that all is inside the logarithm because it's all one term. Now, log base 3 of 2 times x to the third y to the second. The first thing I want to do is use the product rule to split up the three products that are here. 2 times x to the third times y to the second. Okay, if I do that, I split each of these up to their own logarithms separated by plus signs. They all have the same base as well. Log base 3 of 2, log base 3 of x to the third, log base 3 of y to the second. Okay, and the goal here is you ultimately want only one thing inside each logarithm. I've already got that here. I don't have that here. I've got x to the third. I just want x. So I'm going to use the power rule to bring that 3 down. And I'm going to do the same thing over here. I'm going to use the power rule to bring that 2 down. And so I end up getting my final answer, which is this. Log base 3 of 2 plus, bring it down, 3 log 3 of x plus, bring the 2 down, 2 log 3 of y. For our next example, I'm going to go ahead and use ln. Nothing special about ln. That just means every time I write the log now, I'm going to say ln instead of log base 3 or log or whatever. So I've got a quotient here that I want to go ahead and get rid of first. So I'm going to take the first part and the second part and separate them, the top and bottom, separate them with a subtraction sign outside of the logarithms. So now I'm going to say ln 3x squared minus ln y. So the numerator and denominator split apart with a subtraction sign outside of the logarithm. Okay. So the next step is to break this 3x squared up into 3 and x squared. These are multiplied together. So I'm going to break them into two separate logarithms using the product rule. And now the only step is to get that squared down here using the power rule. Everything else just comes down. And this is what you get. Okay, some other examples. We're going to do kind of the opposite here. Instead of expanding, we're going to write this expanded thing into one single logarithm. So I want to kind of put all this stuff together. A couple of ways you could go about this. I think what I'm going to do first is I'm going to distribute this 3 first. I could go ahead and rewrite these using the quotient rule, whatever order of operations you would like to do. If you multiply first, just make sure you distribute. And that's what I did. So I'm going to go and distribute first. So I get 3 log 5 minus 3 log 2. And over here, I went ahead and took that 4 and just put it up as an exponent of the x. Now I want to go ahead and use the quotient rule on these. Okay. I'm sorry, no, I didn't use the quotient rule. The next thing I did, I could have. Next, because we have a common coefficient here. But the first thing I did was actually I just put that up as the exponent. So log of 5 to the third power, log of 2 to the third power. Still have a subtraction sign in the middle. And log x to the fourth hasn't changed. Now I've got a minus and a plus. Okay, so I guess what I wanted to do here is 5 to the third, which is 125, 2 to the third, which is 8, and just drop the parentheses for some reason, and let's see what I did next. All right, the next thing I can do is with the subtraction sign, I can go ahead and use the quotient rule here. So I'm going to say 125 divided by 8 inside one parentheses. And over here, I'm going to go ahead and keep that the same for now. Now I can use the plus, I can use the product rule. It means I can multiply these inside the logarithm. So every time I apply one of these rules, notice I'm putting logarithms together. This subtraction, for example, I brought that together into one logarithm by dividing on the inside. I'm bringing these two logs together into one by multiplying on the inside. X to the fourth multiplies on the top. Now everything's written inside one logarithm.